The last section we are going to look at in trigonometry is bearings and problem solving. Now the big difference between a bearing and a normal angle is the direction and the manner in which it is measured. So a bearing is always measured from the north and in a clockwise direction. So if we look at the sketch, we have an axis showing the north, east, south and west. And what we do when we measure a bearing is from the north, we then measure the angle in a clockwise direction, as you can see. So that would be a bearing of 130 degrees. So with our normal angle, we measure from the horizontal axis and in an anti-clockwise direction. So therefore, that will be how we normally measure an angle, and that would represent 130 degrees. So the big difference you will see when you're dealing with bearings questions is to get the sketch correct, because there's a huge difference between the way we would measure an angle and the way we would measure a bearing. So let's look at the example on page 89 to illustrate this. We are told that a hiker starts his hike on a bearing of 64,3 degrees and he travels on this bearing for 6 kilometers. He then changes direction on a new bearing of 150 degrees and hikes for a further 3 kilometers, at which point he is exactly in line, or that's the same as due east, with his starting point. Determine how far he is from the starting point. Now guys, in order to attempt this question, we have to make an accurate sketch of what's going on. So let's do that. We start by showing this all on the diagram as follows. We are told that he starts his hike on a bearing of 64,3 degrees. So remember, we measure that from the north and then in a clockwise direction. So therefore, this angle is 64,3 degrees. But then remember, these are perpendicular to each other. These axes are perpendicular. So therefore, if that's 64,3, and if this whole thing is 90, then 90 minus 64,3 will give me this angle here. So if we put that in a different color, that angle is going to have a value of 25,7, and I get that by saying 90 minus 64,3. He walks on this bearing, or at this bearing, for 6 k's, at which point he then changes his bearing. So when he changes his bearing, we now have to impose another system of axes there where we can measure from. So he walks for 6 k's, and at that point he's going to change direction. So once again, we draw in the north, east, west and south lines, and we measure in an anti-clockwise direction 150 degrees, which is what his new bearing is. And we know that if that's 150 degrees, then using angles on a straight line, this little one here inside the triangle now would be 30 degrees. And he walks on this bearing of 150 degrees for a further 3 k's. So we're now going to take all of that information that we got from the bearing diagram and put it into a triangle so that we can work out his distance from his starting point. So as you can see, we know that AB is 6 k's. And I've shown you before that that angle is 25,7 because we took away his bearing of 64,3 degrees from 90 degrees. Using angles on a straight line, we saw that if this bearing was 150 degrees, then this little one here inside the triangle would be 30 degrees. So therefore, at that point, we can drop a perpendicular, and we know that the angle formed between those two lines would be 30 degrees. And we know that he walked at that bearing for 3 kilometers. So therefore, the distance we are interested in is this entire distance, AC. Now guys, in order to work out this entire distance, AC, we cannot work immediately in the big triangle. We have to work in each of the little triangles and then add up the two values to get his total distance. So therefore, we need to work out the length of AD, add that to the length of DC, and then that will give us the total distance from A to C. Alright, so the first thing we're going to do is work in triangle ABD and work out the length AD From the given information, which is AB is 6 kilometers, we've got the angle is 25,7, and we know that BD is perpendicular to AC, so therefore angle D is 90 degrees. So in triangle ABD, just as we did with all our trig applications thus far, AD is going to be adjacent to 25,7. AB will be the hypotenuse, and then BD would be the side that's opposite angle A, so opposite 25,7. So therefore, if we set this up, we've got the hypotenuse, we're looking for the adjacent, and guys, you should know by now, adjacent over hypotenuse is the ratio for cos. So I can say cos of 25,7 would be the adjacent, which is AD, over the hypotenuse, which is 6. So therefore, using my calculator, if I times both sides by 6, I will get that AD is 6 times cos 25,7. So it's 6 times cos 25,7. And that gives me an answer of 5,406. Once again, we're not going to round this off at this point, because we are going to use it to help us to determine the entire length AC. So we're not going to round off just for the sake of accuracy. The next thing we have to do is to work out the length of DC. So we've just worked out the length of AD. In order to get to the length of DC, I now need to work in triangle BCD. Now in this triangle, we know that BD is perpendicular to AC, so therefore that angle is going to be 90 degrees. We have worked out from the diagram with the bearing on it that angle DBC is 30 degrees. So we can work out angle C, if necessary, is 60 degrees just using angles in a triangle. If I work from the given angle, which is 30 degrees, then we can see that the side that we are interested in is the opposite side. The 3Ks, which is given, is the hypotenuse, and this BD is the adjacent side. We are interested in working with the given information, and we have to work out the unknown, which is DC. So therefore, I can say working from 30 degrees, we are looking for the opposite side. We are given the hypotenuse, and you should know that opposite over hypotenuse is the ratio for sine. So therefore, I can say sine of 30 degrees is equal to my opposite side, which is what I'm looking for, over the hypotenuse, which we have worked out from our bearing diagram. So therefore, CD would be equal to 3 times sine 30, timesing both sides by 3. And 3 times sine 30 will just give us a value of 1,5. So we've got that CD has a length of 1,5. We've already worked out the length of AD in the previous part as 5,4 and some other decimal places. So therefore, in order to get the length of AC, which is his distance from his starting point, all I have to do is add AD and CD together. So therefore, AC is going to be equal to CD plus AD. So that's going to be 1,5 plus 5,406 and so on decimal places. Can put that into the calculator. Remember, we kept the answer from the previous one. We must only round off right at the end for accuracy purposes. And we will get an answer of 6,9 Ks correct to 1 decimal place. So therefore, he is 6,9 Ks away from his starting point. Guys, so we've come to the end of a very important section in grade 10, and that's trigonometry. Please understand and apply all the concepts that you have learned here to the activity questions. And as I said, this is a very important section. It will come up once again in grade 11 and grade 12.